I'm back.
Wait.
Missed the vlogger too, but I'm back for the last final lesson in Module 2. Today is Module 2, Lesson 19, the Euclidean algorithm as an application of the long division algorithm. What? That's a mouthful. Now, I'm always very honest with you. I always tell you the truth. I have never seen this before last year with the new curriculum. But I got to tell you, it's really kind of cool. It's just a new way to look at something. So hang in there, and it'll be pretty neat by the end of it. I don't think we're going to do all of Lesson 19 today. We'll start Lesson 19, so your homework is only number 1 on the problem set. And then on Monday, we'll do the word problems for Lesson 19. And then we'll do our review stations Tuesday, Wednesday. Thursday, we'll go over our review packet. And Friday is your Module 2 test. There's extra help every day next week, so we're in really good shape. All right, so, okay again. So we have been looking at finding the GCF of 2 numbers, and we've used different strategies. We know that we can make a list. We can list all of the factors of each number, and then look for common factors and circle the largest number. But if we're really using really big numbers, that can get tricky because we have to know all of the factors. And with the list method, it's very easy to leave out a pair of factors, and then that could give you the wrong number. But for smaller numbers, making a list might be your method of choice. This week, we looked at using prime factorization, where we used factor trees to break down the 2 numbers, and then we sorted the factors into a Venn diagram and multiplied them together to find the GCF. That's nicer with bigger numbers because the factor trees, we can't leave anything out. However, if it's really big numbers, our factor trees could turn into a forest because our factor trees will go on forever trying to find all of the prime numbers. Because remember, factor trees give us all of the prime numbers for factors. Today, we're going to look at a method that works with really big numbers, which is why it's kind of neat. It's called Euclid's algorithm. Say what? Okay, Euclid's algorithm is used to find the greatest common factor of 2 whole numbers. So today's lesson is inspired by Euclid, a Greek mathematician who lived around 300 BCE. Why it took Common Core to dig Euclid out of the grave and bring this method to us, I don't know. But it's pretty cool. I'm glad that they did. I like seeing relationships between numbers and number patterns, and I just think this is pretty cool. Because I'm a math geek, and I think it's pretty neat. He discovered a way to find the greatest common factor of 2 numbers using long division. So today we're just going to divide and use division to find the GCF. Now here are the steps 1 through 4, and they're on the top of page 81 in your packet. So under the opening exercise, I suggest you highlight or circle with your colored pencil these 4 steps. Now I'm going to read the 4 steps to you, and they might sound a little wah-wah, but it'll make sense once we practice it. But tonight when you're doing your homework, if you get stuck and you don't remember the steps, well, voila! Here they are. So highlight them, and I'm sure they'll lend you a highlighter if you don't have one. Okay, Euclid's algorithm. Step 1, divide the larger of the 2 numbers by the smaller one. If there's a remainder, divide it into the divisor. Continue dividing the last divisor by the last remainder until the remainder is 0. I told you, wah. Let's just do it. But I want you to know the steps are there, and these steps will make sense after we do it. Okay? So let's just try it. I put the steps here in red so we can reference them. I'm going to ask you to turn to page 82. We're going to skip the model and jump right in. Okay. Now, let's think about a reasonable answer. If my two numbers are 30 and 50, I know that my GCF has to be what? How can I tell if it's reasonable? My GCF will be what?
Smaller than the...
It'll be less than or equal to what?
The two...
Which one?
The denominator.
The 30. The smaller of the two numbers. So I know my GCF has to be less than or equal to 30. So I have that in the back of my head. Now I'm sure some of you have an idea of what the GCF is already, because these are numbers we could solve mentally. And that's good. It'll help us determine if it's a reasonable answer. All right, what is step one? Let's just do this. Let's do this. We're going to start down here under the double I, like the number 2. What is the first step? I know I'm not as exciting as snow, but snow we see all the time. This is the first time you've ever seen Euclid's algorithm. How can you be looking at snow? It's Euclid's algorithm. This is so exciting. You've never seen this before in your life. This is the biggest snow here. So what is step 1? 3, 2. Rebecca, thank you. What does it say to do? Step 1. So take the larger number and divide it by the smaller number. Work all the way to your left because we're going to be working across the page. So start under the double I. All right, so the bigger number goes in the house. The little number goes outside the house. I like the way some people are paying attention and writing their notes. Try not to say names on the bottom. Okay, so we can divide that. 1, 30, 20, but stop. Normally, if we were dividing, we would add our annex 0, gentlemen. We would add a decimal and a 0 and keep going. But we're not going to. What does step 2 of our method tell us to do? If there's a remainder, so here's, actually I don't want to circle that. If there's a remainder, we're going to divide it into the divisor. What was my divisor in the first equation? What was my divisor? This is where the vocabulary comes in handy. What was my divisor in 50 divided by 30? 30. So, my divisor was 30. Now that becomes my dividend. It's almost like leapfrog. So does everybody understand how I set up my second division equation? My remainder became my divisor. My divisor became my dividend. Okay? Let's divide! Yay! So 1, 20, 10, stop.
Did we do the same thing?
Do the same thing. So my 10, my remainder becomes my divisor.
Finally.
My original divisor becomes, not my original, my last divisor becomes my dividend. Boys and girls, the talking over me needs to stop, please. So now we can divide again. 2, 20. Okay. We got to 0. I don't have a remainder. But the point here was not division. The point here was to find the GCF. Look at all those numbers on the board.
Which one's the biggest?
Which one is my GCF? Now, using mental math, I'm sure you were able to figure out the GCF of 30 and 50. So where in there, I could just tell you what the answer is, but I want you to figure it out using mental math. Where do you see the GCF? What is the GCF? What do you think? It is 10. Our very last divisor is the GCF. So you can highlight that with your highlighter. And then we're going to label our answer. The GCF of 30 and 50 is 10. Remember, you always want to clearly identify and label your answer. I don't want you going through all your division and circling and swooping and all of that. So who has a question on where did the 10 come from, the 2, the 20, the 30, the 50? Why did you do that?
Well, we need to do 3 division problems.
Not every time. Sometimes we might need 1, we might need 2, we might need 4. Let's do some more to practice. All right, what is the GCF of 30 and 45? So work all the way to the left. So we divide what by what?
45 by 30.
Awesome. 45 divided by 30. 30 goes into 45 once. 30, 15, and we stop. 15 becomes my new divisor. My last divisor, 30, becomes my dividend. Divide by 2. There, stop. So this time we only needed 2 steps, Nick. We only needed 2 steps this time. But my question still remains, what is my GCF? What is the GCF, everybody?
50.
Awesome. So let's identify that. Is it reasonable? Remember, our GCF has to be less than or equal to 30. And 15 is less than or equal to 30. So we could do our reasonable check.
I just know.
Okay, let's keep going. Now, they put these two side by side on the paper. So you have to really work carefully. So for example 2, go to the left, all the way to the left, and find the GCF of 96 and 144. See bigger numbers. So factor trees or lists would have been time consuming. So go ahead and try this one on your own. How are we going to start? How do we start?
Put the bigger number in the house and the small number in the house.
Bigger number in the house, smaller number outside. Or 144 divided by 96. Or the bigger number, 144, is our dividend. 96 is our divisor. So go ahead and try it. And the answer is, everybody, what'd you get? 48. 48. Are there any questions on that one? All right, try the next one. The GCF of 660 and 840. Now, don't, boys and girls, please stop the chatter. This may seem intimidating because it's large numbers, but 660 is actually pretty close to 840. And you could just estimate in your head, well, 600 times 2 is 1,200. And that's way bigger than 840. So you know what goes in one time. Start to the left as far as you can for this one. All right, let's take a look. Just because it's another step or two, that's okay. Ready? There you go. Oh, dear. Oh, my God. Being neat and organized, as always, is very important. So when you first divide by 1, your remainder is 180. Your remainder becomes your divisor. Your divisor became your dividend. And then just keep repeating. Your very last divisor is your GCF. And then you identify your answer. The GCF of 660 and 840 is 60. So on your homework tonight, make sure you start to the left, work all the way across, and we'll do the word problems for lesson 19 on Monday.